Hello and welcome to this lesson in Introduction to Programming Microcontrollers, in which we're going to be looking at using ultrasonics. Ultrasonics can be really useful in your control systems and robot projects. We can use them to detect if someone's too close and make your robot reverse away. We can use them for measuring water depth in tanks. We can use them to react if someone gets too close to your system. They're used in burglar alarms and sometimes in car alarm systems. So the wiring is really simple. You can see by this diagram it's just positive and negative going to the ground and positive rail of the ultrasonic, and they're quite good at handling different voltages like 3.3 to 5 volts, and it's just two wires going straight into our microcontroller. So what we're going to do is we're going to go over to Tinkercad. This will probably be the last lesson where I use Tinkercad. From here on in it is going to be going over to the actual boards itself. So I'm going to create a new circuit. I'm just going to start by again dragging an Arduino across. I am going to use a breadboard just to make it look a little bit easier in the way that we might actually do it rather than on my first image where we just showed it directly connected. And I'm going to now look for the ultrasonics. There we go, we've got the ultrasonic. There's a 3-pin one, and then there's you can't quite see it there, I'll move that over a little bit. There's a 3-pin and a 4-pin. I'm going to be favouring the 4-pin connector because that's the one that I generally purchase. So there we go, we've got that dragged across. I'm going to do what I've done with previous ones, which is I'm going to hook up the 5 volts to our 5 volt rail. I'm going to hook up the ground to our ground rail, and again I suppose I could make this look a bit prettier. When I'm working on a real breadboard, I actually do plug it in, so I'm just going to connect that up, which is the way you can sort of perhaps see on there. It is plugged directly into the breadboard. So maybe I shouldn't have connected it like that, but I will leave that for the moment. So I can connect the ground to our ground pin. Again, I know this is going to look a bit messy. I'm going to connect our live wire. Oops, don't want to do that one just yet. That one to our ground wire again. I know this looks messy. I'll just choose orange. Nope, didn't want to do that. There we go. So now I'm going to put our trigger pin. This does really look messy, never mind. Trigger pin is just going to go to 9. Now it doesn't actually matter which one because we're still just using digital information. I'm just using 9 because of habit. And I'll just choose another wire colour for the other pin, makes it a bit easy to see what I'm up to. And that's just going to go to pin 8. Again, I'm sure some of you are upset with how messy that looks. Please feel free to make yours much neater. But that's as far as the wiring goes. So now let's jump into some code. Again, we don't want blocks. Continue. Okay, so we can see it's got the original blink code, so I'm just going to delete that for now. Well, not for now, but I'm going to delete it completely. So we've got the void setup, we've got the void loops inside setup. I'm going to just start something called serial.begin, and that's going to start at 9600. That allows us to then see the data coming back over the USB port. Hoping I've got the grammar correct. Yeah, that's fine. And I also like to just do a little serial.write, and I want to know that it's actually working, so serial.println, and I can just sort of say starting up. And that's just my way of saying some data through the USB port so I can see that it's actually booted up the chip and it's not crashed or something's failed or it's dead or something else. Okay, so our next step is I want to create a function called void setup sonics. This is where I start to try and put better coding practice in. So I have this little function that will initialize our ultrasonics, and it's going to look a little bit like this, although there's a bit I've not done yet. So it's going to say pin mode trigger pin is an output, pin mode echo pin is an input. I'll just zoom that in a little bit. So I like to use actual names here, so we can see that we've got the trigger pin and the echo pin, but I've not actually declared these, so I'm going to have to do that now. And I'm going to do that using defines. So this basically sees, whenever it sees trigger pin, it will replace it with the number 8. When it sees echo pin, replace it with the number 9. Now again, if you see code like this, do make sure that your pins actually match the wiring. It's really simple to mix them up and change them around. It shouldn't blow them up. As long as you've not mixed up the voltage, obviously it'll just not work. So let's have a quick look. So 8 is definitely going to echo pin, 8 is echo pin, right, so I have messed that up. So again, it's really important we can flip those around. I'm just going to do it through code. It's not a big deal. There we go, I've just fixed it. So again, let's just confirm trigger pin is definitely on the orange. Orange is definitely going to pin 9. Yep, that's okay. So now it makes it really easy by using the names instead. If you change this over to say one of these boards, then we'd need to change the pins again because this doesn't have a pin 8 and 9. So I've got the setup. Inside setup, I'm now going to make sure I call the function setup Sonics. So that is going to, obviously, when it reads that line, it will call Subsonics and initialize it, and it will output the print. So if I was just to pop up serial monitor now and press run, there we go, starting up, Ultrasonics ready. And I'll just stop that. And if this was plugged into your USB port, it would send that data back into your Arduino IDE. Okay, so the next thing I want is I want a function where I'm going to read this data. I want to get the distance that's from the Ultrasonics to well, however far you're measuring. I'm just going to copy and paste my little function for this, rather than you watching me type it all out. So I've got a function called getDistance. Now it's using a long, not an integer. A long is, I believe, it's basically it can have twice as many bits as an integer, so it'll store more data. So I've got two variables called duration and distance. So it's got a digital write to the trigger pin low. These are just comments I made absolutely ages ago. I'll get rid of those, don't need them now. So the trigger pin low will basically make sure that this is quiet, because it's basically working on echolocation. So it's going to set the trigger pin low, it's going to wait 2 microseconds, it's then going to write the trigger pin high, so it's going to send a ping. It's then going to wait 10 microseconds, and then it's going to write another low. So it's just making that ping, and then the duration is the pulse in, so it's going to read the echo pin, and it's waiting for one to emit the sound, one to receive it, and it's going to measure that distance. And then the distance, duration, divide by 2, divide by 29.1. I did not do the maths for this. Someone else works that out. I just use it, and that basically returns us the distance in centimeters. So now I can output that. I could just say serial print line distance, and that will output it so we can see what's happening. Now if I was to run this now, this still won't work because I've not actually called that. So what I can do inside the loop, I'm going to say get distance. So now I've got get distance, which is going to obviously call this function, do all this, and then it will output it. Now just because I don't need this to run really fast, and I know I've said don't use delays, I'm still going to use delays, because this again is just us prototyping ideas. It's not a real-time control system. Oops, I've made a mistake, I forgot the semicolon. Again, I'm using the errors to read what it's actually saying. So let's try again. So now we should be able to actually measure, so it's saying there's something that far away. So every second, and if I now move this, there we go, we're no longer in range. What do I expect? Oh, there we go. Again, because I'm using OBS to record this, it's making this go very, very slow. But we can see it's got some measurements. I'm just going to change one bit and say print line. Oops, I can't make a difference while it's there. So I'm just going to say print line. That will automatically add a carriage return at the end of the sentence. Oops. Again, this is just a Tinkercad problem. Okay, so there we go. We should be able to now see it's measuring, there we go, the centimetres away. Now what I like to do as well is, from personal experience, anything less than about 20 centimetres can be a little bit glitchy, and certainly anything more than 3 meters it becomes not as reliable, and over 5 meters also doesn't work. So I'm going to put a little bit of validation on. So I'm just going to delete that previous line. I'm going to stop the code. Just put this in here. I'm just going to say if the distance is greater than 300 or distance is less than 30, so 30 centimeters to 3 meters range, I'm going to say it's out of range. Else I'm going to print that distance, and I'm also going to add the value, the units, centimeters to it. So now when we press play, we should be saying, look, it's out of range. I bring this back in, we should now be in range. Once it comes up, there we go, we're 206 centimeters away. Okay, so I've just made the wiring a little bit neater, make it easier to look at and play with. So we're now going to try and make it just do something a little bit more useful. So I'm going to add an LED and a resistor. So the first thing I'm going to do is put the resistor between the ground rail and the positive. I'm going to make sure this is 330 ohms, which is the common one that I tend to use for LEDs. We're going to drag an LED across, and I'm just going to connect pin 2 to our right hand leg. So now this is creating the full circuit here. So I'm going to go into the code. I'm going to go pin mode, and this is hooked up to pin 2, so I'm going to say pin mode 2 is an output, and then I'm going to go into our loop. And what I'm going to do now is, this was obviously calling this function, but this is returning this data type, or at least it should be. So if I just say return distance, so if it has a data type there, it means we have to return something. I'm surprised it's actually compiled. So I'm going to return the distance that we've just calculated here. So really, I could get rid of all this now. I don't need that little bit of code, so I'm just going to comment it out. So it's going to do the calculation and then return the distance. So back up in here, I can now say if get distance. Because there's a function, well, it's a sub-function selection statement, I'm now saying if get distance is less than, so I'm going to say if it's less than, say, I don't know, 50 centimeters, we want it to do something, in which case we're going to just light up the LED. For those who've got cars with reversing beepers, this is how it's working. I can now just say digital right pin, so pin 2, and I can set it to high. And of course, if it's not, if it's greater than 50, so I'm going to say else, and I'm lazy, so I'm just going to copy that line again. Oops, I'm going to get an extra bracket there. I'll just get rid of that one. I'm just going to say digital pin low. So now, hopefully, if I've done this correct, this should now light up if the distance is too close. So it's 132 centimeters away, so let's just reduce that number. Oh, nope, it's not liking it. What mistake have I made? Okay, one quick mistake I'd made was the resistor. I'm sure some of you probably saw it and were shouting at the computer screen. I named it that. That's not it. Let's just call that resistor, and it should have actually been there. 330 ohms. I knew there was something wrong with the colours, so let's try again. So I'm also going to take out this delay because that's slowing everything down, because we know this is running a little bit slow. Okay, so now I'm clicking on it, moving the distance around, coming down. And there we go, the LEDs come on. So again, we could now hook that up to a buzzer. We could do more LEDs based on how far away it is. So again, I think that's all I need to show you for today. Next lesson we will definitely be moving into the real board, where we'll do this for real on a proper ESP. And if you've liked this video, please remember to like, subscribe, positive comment below, and please feel free to leave suggestions for future content. Shall see you in the next one.